Do you see a rabbit?
Yes.
You got it.
Awesome. Okay, so this is my presentation on Bencher, catching performance regressions in CI with a bite-sized NOM tutorial. I'm Everett Pompeii. That's my email and the repo link on my GitHub. And so yeah, what are performance regressions? Just in the general sense, right? This is when your software gets slower or some metric you care about gets worse. So this is just a simple graph of latency of, hey, you had a real bad Sunday, I guess. And you like quadrupled the time it takes for your software to run. So when do performance regressions get detected? This is an overly simplistic development lifecycle where you have dev and it goes to CI and then it goes to production. In development, you can do local benchmark comparisons. In the Rust ecosystem, Criterion is very popular. And then in production, you can either hear from your customers or use observability tools. There's a whole bunch of them. But there are kind of problems with these as far as detecting performance regressions. It's local only for things like Criterion. It saves it in your target directory. And then for observability tools, that's kind of too late. You've already shipped poor performing code. So why not in CI? I kind of ran into this earlier this year and started to research and say, you know, there has to exist something for this, right? And JMeter is a thing. I don't know why this is still black, but it's Java only. Then Android Studio has a thing, but that's just for Android. There's a thing called SciBench, but that's only for Java and it's SAS only. There's a thing I found called Speed Curve, but that is basically website only. It's just kind of like for fast web pages. And then the closest thing was a thing called the Phoronix Test Suite, which is a kind of its own test harness and everything. So it does do all the saving and backending and comparison stuff that I was interested in, but you have to use its test runner, which I did not want to do. I wanted to be able to use my own test runners. So and I was like, how does like MFang solve this problem? They surely have run into this. And so Microsoft wrote a great blog post about how they catch performance regressions. Facebook, I guess Meta now, if we all will call it that, has two great write-ups actually about doing this for both the web and mobile. Netflix, Chrome, and Google also has a thing called Skia, which is a UI framework that has a pretty insane performance like benchmark suite extra tool. It's its own insane level of software. But all of these are just closed source still. The Netflix people said they might open source and stuff, and they still haven't. So reading these and kind of internalizing it, I came up with Bencher, which the goal is to detect performance regressions in CI, make it open source, allow you to self-host it, and to design it so it can be used for multiple languages, Rust, Java, Python, Node, and such, given the tools that I kind of currently work with, wanting to use them on all of them. So just a kind of high overview of like the architecture of the system. You have your like benchmarking tool from whatever tool you want to use, say Cargo Bench here. That gets wrapped by the Bencher CLI, which will then take those results and throw them over to the API backend, which is also written in Rust. That gets saved to a S3 API compatible backend. So if you want to self-host, that can also be Minio, or if you're cool with just using S3, you can use that too. And then you can go and view your results in a web GUI. So first, we're going to kind of take a look at how you parse the benchmark output. And this is our little NOM tutorial in here. So this is just an example running Cargo Bench. And we're going to parse this. So parsing the first part, that running command, I kind of have this color coded, but the red is the red, The orange is the orange. So this is the nom essentially that so you look for a line ending, then you look for a tag running, then you look for a space, and then you look for a digit, and then you look for a space. And then you have alt tags here, which is, it could either be tests or test, because if you have one, it's singular, and if you have more than one, it's plural, and then you have an ending new line. And so that's a like kind of real basic like parsing and nom. And then now that we're done with that, we kind of get into a little more complicated here. We have a bit more variety with the actual test being run. And so this whole thing can happen 0 to many times. So that's the many to 0 here. And then there's also a tuple, which is just the way in nom of grouping all of these things, which should be pretty familiar as Rust developers. And so again, a new line and the tag tests, a space, and then here we're going to take until a new line. So this doesn't take the new line, it just takes until it. So this gets everything until we get a new line. So this is basically the name of our benchmark here. And then we have another space, and then we have an ellipses, and then another space. And then here is where we kind of handle whether it's ignored or if it runs a benchmark here. And so the ignored tag just simply goes into an enum, which can either be test ignored or a test bench with the parsed bench inside of there. And then it has a line ending. So with that, we're going to kind of dive in here real quick into parse bench and take a look at that. So parse bench, you have that benchmark, you have a space, quite a few spaces, and then a parse number, which is another function call we'll look at in a minute, another space, the take until slash, which gives us our unit, and then we get per iteration, and then we also get our variance over here by coming over. And again, that's parsing the number. And so last level down, we'll look at parse number, which just, this takes, again, you need to at least have a number and a number, and then a tuple, because you can have multiple numbers in a row, and it's a digit, or possibly a comma. And the success here is saying like it doesn't have to be here, right? So like this number doesn't have a comma anywhere in it, and it's good. So we just do that multiple times and accumulate those digits, and we end up with an actual number. So yeah, so just at a kind of high level, that was going and getting the running test piece all the way down to here. And then I was lazy, so I just ignored this block down here and didn't care to parse it. And so this is kind of what these look like, sort of pretty printed. And at the highest level, parsing this, you do again, a tuple with this whole parsing of this standard out here. And then we map it. So all we really care about in there was those benches, those benchmark values. And then we do our own map function to create JSON that gets sent out. So that was a little brief nom tutorial that's used in the CLI, and that gets sent back over to the API. And on the API backend, there's performance regression alerts. There's a z-score and a t-statistic, or sorry, t-test. I am not very good at stats. So if anybody's good at stats, please come, like, let me know, message me, feel free to like review this part of the code, because I'm using cumulative probability functions. And the idea is that you're sort of able to, whether from the left-hand side or the right-hand side, kind of say a percentage that you want to kind of bound within. And so if something lands out here, you'll get an alert, but if it lands in here, then you won't. And this is kind of a percentage of the total area with those distributions. So both for the z-score and the t-test, which means that like something like this would generate an alert. And the CLI is set up to receive the alerts back and you can have it fail on alert. And so that way you could fail your CI builds if you want to, based off of alerts getting generated. So that's kind of a overview there of the architecture. It's pretty simple. And this is just kind of a little look at the UI, like as to what the charting looks like. I can actually do a live demo. I'll turn off my dark reader here. So yeah, you're able to, at least at this point, you can filter by date and things like that. There are different metric types: throughput, compute, memory, and storage. So far, I just really have latency being run with my basic tests. And you can kind of compare whichever ones you want here, and also filter and add them. One of the things that made things a bit more complicated, but I wanted to make sure to do, was that you capture both the complexity of having branches and test beds for the benchmarks. So it's sort of a three-dimensional matrix of branches. So you can have like master, devel, and so on. And then the test beds, so whether you're on some like a Linux runner or a Windows runner or things like that, then those benchmarks are tied to that pair of branches and test beds, because they're going to be different, obviously, right? Like, so like running on devel is going to be different than running on master, as well as based off the test bed, if it's a Windows or a Linux runner. So yeah, that is kind of just that real quick. I can hop back over into that if anyone has any more questions. And that's the UI. And so when do performance regressions get detected? You can do it in dev, manually, local only, or do it in production with unhappy customers, or with Venture and like detect performance regressions in CI. It's open source, self-hosted, and multi-language in theory. At this point, it is just a single REST adapter. So yeah, that's it. And thank you guys. Are there any questions?
Are you only capturing time-based metrics?
No, so it's not just time-based. So like the throughput, compute, memory, and storage is a like the throughput would be a events per unit time, which you can define, and then the compute, memory, and storage are up to you to sort of come up with however you want to measure that. Those are like much more flexible, and they just have a min, max, and average value for you to.
Are you assuming that we're following your output convention?
Yeah.
Is that how it works?
Yeah. Here, I'll come over. So this is the Swagger docs here. So the piece that gets sent over is the reports here. And so like this would be the kind of convention for what gets generated by the CLI, or what can get sent over to the server and be considered kind of part of that. I guess this doesn't really fill out the benchmark information in here, but that's where all those metrics and things are. So yeah, you don't have to use the CLI, right? If you just want to, if it comes out in this format, which I've tried to make as kind of adaptable and extensible as possible. So yeah, let me know if you see anything that could be improved with it, you think.
So what's the reason to choose to parse textual output from criterion instead of just using the CSV output?
Yeah, so this one is actually not using, this is the just unstable Rust bench and not criterion at this point. For this one, it's just the base Rust bench, which doesn't have a non I could, at least when I was digging through the docs, I could not find like a different variant of output. Criterion is the next on my list, I guess, to go and start to parse. And so I currently have a thing that, can just parse the JSON in. And I probably would do a similar thing with the CSV from that. But this is not currently Criterion, if that makes sense.
What was the motivation for having right? The client is parsing is the client parsing the benchmark output or the benchmark output before sending it to the server? Is that right?
It is. Yep.
Did you consider just sending, like the raw lines to the server and having it parsed over there?
Yeah, I thought about it. And you can just put a blob and tag it and have it go do its thing. I was trying to have it to where you could still run things locally as much as you wanted to without having to hit the back end for some things. If you wanted to do runs and things like that. But yeah, it's yeah, you could definitely, it is definitely doable. The other piece is either way, the alerts, you'd want to get back the alerts to be able to fail on them. So it's just as a, yeah.
I have a question regarding detection of performance regressions. It seems you're using statistical tests, z-tests and t-tests to be able to tell if the changes are meaningful regressions or just some noise or changes. So one thing I actually faced when benchmarking code was that the timings depend on how busy your target computer is, whether it's your personal computer or if it's running on a CI, if it's just GitHub actions, and sometimes it gets just busy and or deprioritizes your workload. Do you think these statistical tests would be able to catch these circumstances well, where the mean of your samples are consistently different in two different runs, and that's not because of any changes in your code or any regression in your code, but because just the workload on the server changed?
Yeah, it's a great question. So there are kind of two ways to answer that. So the first one is like using the statistical methods. And again, I'm not like super stats expert, but like you're gonna have, if you have more variance in that, and basically the normal amount that you're getting back, then like you're gonna have a much wider distribution. And so it does make it so that way, like you can't put your like kind of cutoff as close with that. The write-up from Facebook back here, quite a ways back here, they did a really good overview of how they tried to cut down on that noise and like all of the steps that they went through to kind of go and like take it from this to this as far as the kind of variance goes, which allowed them to detect, kind of set that threshold a lot tighter in there, and detect like 5% performance differences as opposed to like 30% performance differences. And so unfortunately, I don't think that's something I can really help with from this end of the tool perspective. It has a lot more to do with, like you said, the runners and things like that, and probably like getting bare metal servers and stuff like that to run your benchmarks on.
Oh, that's great. Would you be able to post a link to that Facebook page?
Yeah,
Yeah.
and I can also here. I'll put my slides up. I'm just going to post this
That
in
would
the
be
chat
awesome. Yeah, thank you.
because I made sure to hyperlink everything in here because I figured I would share it out. So
I should also point out that I really like your logo. I love it.
thanks. There we go. And can I get chat? Chat. There we go. Cool. Okay. So that's and feel free, Scott, if you want to post that somewhere. Yeah.
Oh, I wanted to ask, what did you write your front end in for looking at the reports? Is that yours?
Yeah. So if you go dig through the repo, I have tried every single like build front ends with Rust library create that there is, and I eventually just gave up. And it's written in solid.js and like TypeScript / any script.
Okay.
Yeah, it's I really tried. Like so much. It was just in different projects over time, like trying to do Rust front ends, and it just was rough. So
What are your main annoyances?
well, the big thing is I wanted to use D3.js, and so I was going to have to do JS interrupt to do that. Which I guess there's like plotters, which I didn't really know about at the time, but it's not quite as web native-y to eventually, because like right now I've got like this thing that's not the best, but I hopefully would improve it over time with the graph. And then yeah, it's just I don't know, it was just rough going.
At least when I've done it, building the front end stuff in Rust can be a lot slower than like regular builds in Rust. Maybe it's just because it's been so long since I've done it, but combining those with like a graphing library like plotters sounds really, especially when like web development, we're usually used to like a really fast iteration cycle.
Yeah,
that sounds rough.
yeah, so I just but Solid's actually pretty cool. It doesn't have a virtual DOM, and it's sort of like a middle ground between React and Elm. If anyone's ever kind of used both of those, it's not as hardcore. It's not like pure functional, but it is actual reactive programming, unlike React hooks, which are a little kludgy. So yeah.
Do you have an example of? Oh, sorry, was somebody else?
Oh, no,
I was going to ask if you try to use trunk to wrap existing JavaScript libraries.
Oh yeah, it was just it's I guess at a certain point I have not no. A lot of my like exploration was pretty early. It was probably about a year ago before I started working full-time in Rust, and so I'm sure I would probably understand a lot of it a bit more. But then when I was like, I want to do this project, I was like, I know what I want to build, and the amount of time to spin up and do that stuff, I managed to learn the solid framework pretty quickly compared to but just personal experience, I guess.
I was curious what the deploy requirements are, and like what if somebody was like, oh, I want to use this, like what would be is there an example of like, okay, here you go, you use like you can do it as a GitHub action, or no, here you would run like you would
Yeah.
probably need like this, you know, ECS configuration or whatever.
So yeah, I have a Docker Compose file here, which just pulls the latest from Docker Hub, which every time I push to master gets built with the latest. So you could get this morning's build if you just use this and do Docker Compose up. You should have a running instance, essentially. If you want to build it yourself from the source, then that's the build.dockercompose file.
What's the backing database?
So it is SQLite, and that was the use of S3 here. What I'm using, well, there's a example here in the API of using Lightstream. I don't have like Docker Compose for it, but you essentially use, so Lightstream allows you to basically take a SQLite database and store it after each write in S3. And writes are free, pretty much free in S3, and you only pay for reads. So essentially, you can continuously back up your database for pennies. So it makes it very low cost to kind of run and use, and it makes it very quick to query because you're all in memory. So yeah.
But it,
so no
like,
caching.
would it be? It sounds like there's it would be difficult to run it like serverless.
Yeah, this is if you also dig back to the repo, I played around with building it out as serverless functions, and I did so much overhead. I just, yeah, and so it's very happily a long-lived service.
Very envious that your performance test can run within 15 minutes of a Lambda function.
Yeah.
Have you started using it for anything yet?
Yeah, I think I'm allowed to say I have deployed this at work. So we are using it in CI at this point to, you know, catch performance regression. So it just happened like this past week. So there's at least an N of 1 deployments at this point, and it has a long way to go still. This is by no means a finished product or tool. It's very much a super MVP still. I just recently got it to where multi-tenancy and everything works. So you could, in theory, kind of have a bunch of people sharing the same box and same deployment.
Nice, awesome.
Yeah. So, yep. So you can, for a lot of the features, you have to use the CLI still. There are not UI GUI equivalents for it. And then I use Clap, which I learned about through this meetup, to use the CLI, to do the CLI. So yeah. All right. Any other questions? Cool. Then I will stop sharing. Thank you guys very much.